Hello, welcome to my channel. Here we are going to learn some different organic compounds that is benzene, how it is formed, and then say some derivatives of benzene. Welcome. Let's pass through different concern about benzene ring. Benzene ring can be prepared from alkyne. Alkyne is an aliphatic hydrocarbon. Therefore, benzene ring can be prepared from alkyne through the question called polymerization. The process is called polymerization. Thus, it involves polymerization of alkyne. Alkyne, how can alkyne lead to the formation of benzene ring? This reaction considers about the presence of some different conditions such as hot iron tube or copper tube. Therefore, here we are required to have iron. Yes, this is iron, and then we must provide heat within the reaction. This iron tube and the present having this as the monomer to prepare benzene ring, we can obtain it as follows. Yes, the reaction will go directly to the formation of benzene ring. It is as follows. This one is the benzene ring as suggested by Kekure. Yes. From there now we can obtain benzene and we can use it for different purposes. Therefore, this is benzene. So how can we obtain amine from benzene? And this is a short question showing the whole process of benzene formation. Yes, we are so interested to know how amine can be prepared from benzene ring. Benzene ring now, as far as it can be used, first we are required to have benzene ring as we have prepared it before. This is the benzene. Yes. So, see benzene ring as that one. In order to get amine, we have to form first nitrobenzene. Therefore, we are required to have nitric acid, concentrated nitric acid. This is concentrated nitric acid, and there we must have also concentrated sulfuric acid. Concentrated sulfuric acid. One can ask, what is the function of sulfuric acid in the reaction? Sulfuric acid acts as a catalyst to produce, but also it can act as a dehydrating agent, removing water that can be formed during the formation of nitrobenzene. Therefore, from there now, we are so interested to know how it is used. Okay, here the reaction will be as follows. Yes, this is the nitrobenzene as this one. Okay, yes, likely to be like that one. Also, one can need how to choose some reaction mechanisms. From there, how can we know? How can we obtain benzene? Methyl benzene from tail one. This is the nitrobenzene, and now we need to obtain amino group from this one. And this is a short equation showing the process. And here are a few steps to consider about the mechanism of nitration, hence formation of nitrobenzene. Okay, now let's prepare an aniline from nitrobenzene. Nitrobenzene can be drawn in such yes, this is nitrobenzene. We are now showing some conditions in order to get aniline. Yes, we must have different conditions. The first condition is the presence of hydrogen gas and the palladium catalyst. Palladium is a catalyst. Yes, it is a catalyst. Okay. Oh, yes, we must have also another condition, that is the ethanol and alcohol. Yes, it's the ethanol. From there now, it's easily now obtained. Then, aniline can be formed directly through this process. Yes, there is no another addition of other substance other than those which has been mentioned before. Now this is the aniline. We can call it as the phenylamine. Of course, it is the aniline. It's a benzene ring with the amino group attached to it. Yes, this now shows the other process. This is the short process of preparing amine. And this is a shorthand equation showing the whole process. Again, we are interested to know how amino group can be also to para director. That is, how can it direct the common group to also in the para position of the benzene ring. Let's go through the steps here ahead. This is the amino group attached to benzene ring as follows. Yes, this is the amine group. We can call it ethylamine or aniline. Yes, this R is the alkyl group. It can be hydrogen or another alkyl group. Yes, that is how it proceeds forward by showing the direction of electrons. It's now formed the bond. The electrons now start to move from one side to another. The bond starts to be moving from one point to another one. Yes, just form positive charge. The positive charge around there, and the bond starts moving as follows. Yes, we are forming negative charge to the second carbon from the bonded one. A double bond will be formed between nitrogen and the carbon of the benzene ring. Okay, let's proceed now. The other compound is being formed by movement of electrons. Yes, there's the forwards. Okay, yes, like this one, we have now nitrogen. Yes, with one hydrogen, and the other alkyl group, it can also be hydrogen or only hydrogen with no an alkyl group. Yes, this bond electron now move in that direction, while the bond now break as shown. Yes, now the bond has shifted. The electrons is moving. Yes, also the process progresses forward while electrons are moving and the bond shifting their positions. Okay, it goes forward on proceeding. They are proceeding forward by showing the direction of electrons as it is shown below. Yeah, let's proceed forward by showing how electrons are being moving across the benzene ring, starting from amino group. Yes. Yes, let's continue. Right now, it is now the bond is forming there, the benzene ring as shown below. Yes, the benzene ring with the movement of electrons still moving throughout the ring. The bond is still there. Yes, now the whole electrons will be shown as form. The last will be a congruent of all of this one, showing the full direction and the movement, cycling or movement of electrons within the ring. Yes, this is now the last structure, which shows the whole movement of electrons. We're activating the ortho and the para positions of the benzene ring, thereby ready to accept the coming group. Yes, it can be any of electron, any of compound, which is can be as is para, and also this is it is ortho and the other one ortho positions, and activating the para again. From there now, the ortho and the para positions are more reactive or more acceptable to the coming group. Yes, like this one, as it is shown below. So easy and simple to understand. Yes, again, we are so interested to show a movement of electron by methyl group 1O and alkyl